topic for today is on proving triangles congruent, day 1. Objective: students will be able to determine triangle congruence. Question: what strategies do you use to determine triangle congruence? The idea of congruence: two geometric figures with exactly the same size and shape. So here you have to imagine that you need to rotate one of the triangles. So for example, we can rotate the triangle ABC into this form. So this becomes your B, A, and C. So we're comparing F to C, E to B, and D to A. Right? So from our previous example, we can say that angle F is congruent to angle C, and angle E is congruent to angle B, and angle D is congruent to angle A. And the side FE is congruent to the side CB, and the side ED is congruent to the side BA, and the side DF is congruent to the side AC. Right? So from our previous worksheet, we need to compare all 6 of these, so all 3 angles and all 3 sides. Right? So throughout proof, they say that do we need all 6? No. Right? So all we need to show is that if 3 sides are congruent, then the 2 triangles are congruent, or 2 sides and an angle between the 2 sides are congruent, then the 2 triangles are congruent. Or we can show the 2 angles and a side in between the 2 angles are congruent, then the 2 triangles are congruent. Or we can show that the 2 angles and a side not in between the 2 angles are congruent, then the 2 triangles are congruent. So we need to show only 3 of these, not all 6. Okay, so here is the theorem for size. If the sides of one triangle are congruent to the sides of the second triangle, then the triangles are congruent. So here we're able to show that segment AB is congruent to segment DE, and segment BC is congruent to segment EF, and segment AC is congruent to segment DF. So if we're able to show that all 3 sides of one triangle are congruent to all 3 sides of the second triangle, then the 2 triangles are congruent by side. Right? And can notice that before, when we write the congruency, the order is important. Okay, and here's a theorem for angle side. If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Okay, so here we say that AB is congruent to segment DE. So this is AB and DE. And the angle A is congruent to angle D. So then this is angle A and this is angle D. And segment AC is congruent to segment DF. So notice that the angle A and D are between the 2 sides. So if we are able to prove that the 2 sides and the included angle of one triangle are congruent to the 2 sides and the included angle of another triangle, then the 2 triangles are congruent by angle sides. Theorem number 3, angle side angle. If 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the 2 triangles are congruent. So here we're saying that angle A is congruent to angle D, and side AB is congruent to side DE, and angle B is congruent to angle E, then the two triangles are congruent by angle, side, angle. Theorem number 4, angle, angle, sides. If two angles and a non-included side of one triangle are congruent to the corresponding angles and sides of another triangle, then the two triangles are congruent. So here we're saying that angle A is congruent to angle D, and angle B is congruent to angle E, and segment BC is congruent to segment EF. So here we have angle, angle, sides. So then the two triangles are congruent. Okay, so then these are the 4 theorems to show that the two triangles are congruent. Side, side, sides, side, angle, angle, or angle, angle, sides. Okay, so remember these 4. And to prove, they have to come in that order. Right? And we can use any of these 4. Okay. Things you can mark on a triangle when they are unmarked. So, okay, so then when we try to prove, we will mark our drawing. Overlapping sides are congruent in each triangle by the reflexive property. So here we have the green triangle and the pink triangle. They share the same size, so we know that this is congruent between the green and the pink triangle. And we also have learned that verticals are congruent, so that whenever we see our vertical, immediately we mark they are congruent. And the third one is alternate interior angles are congruent by parallel lines. So then these two are alternate interior, and these two are also alternate interior. Right? Notice that for parallel lines, they have the same marking of an arrow. Okay. And it said determine whether each pair of triangle is congruent by SSS, SAS, ASA, or AAS. If it is not possible to prove that they are congruent, write not possible. So here we have side AC is congruent to side EC, so labeled as side. And here we have side BC is congruent to DC, so label that as another side. But then there's no marking on it. But in here we know that triangle ACB is congruent to triangle ECD by vertical angles. Right, so here we have an angle, so then we can prove that by side, angle, sides. Okay, so always label your diagram. Okay, another example. Determine if whether each pair of triangles is congruent by side, side, sides, side, angle, angle, or angle, angle, sides. If it is not possible to prove that they are congruent, write not possible. So here we're given that side JM is congruent to side SK, so label that as being sides. And since they share a same common side, so this is also congruent, so we have another size here. Right, and well, here we see that angle M is congruent to angle K by alternate interior angles. Okay, so here we have, so then we can prove by side, angle, sides, right? Okay, name the postulate. Well, here we see that they are, these two triangles are congruent by side, angle, sides, so then side, angle, sides, and side, angle, sides. Right? And another example is that these are proved by angle, side, angle. So then we label side, angle, side, angle, and angle, side, angle. Okay, so make sure that you label in that order, right? And here we have, so then this one is not possible because we said side, side, angle, and side, side, and angle. Well, I think this one is possible. So then that's a mistake, right? Okay, so then this would be side, side, size, and side, and angle, and an angle. So it should be side, size, and angle. And for this one is angle, angle, size, and angle, angle, size. Okay, and the next one is vertical angles, reflexive, size, and angle. When two triangles touch, there may be additional congruent part, right? So then here we have these two angles are congruent, and these two sides are congruent, and this angle, so this is angle, side, oops, my mistake. Let me erase this. Okay, so here we have these two angles are congruent, so we have angle, side, angle, and angle, side, angle. So then these two are congruent by angle, side, angle. Okay. And here when we look at our marking, we have size, side, and we have angle, angle, and they share the same size, so these sides are the same. So then this is side, angle, size. Okay, name the postulate. So the same thing. So here we're giving you the answer, and you need to label the diagram. So this is side, angle, side, and side, angle, size. Okay. So here we have our vertical angles are congruent. So then will be side, angle, size, and side, angle, size. And similar here, the vertical angles are congruent, so we have angle, angle, and size. Angle, angle, and size. And here, the last one is reflexive, and these two are congruent, and these two sides are congruent, and these angles are congruent. So it should be size, size, angle. Right? So then this is, we cannot use that. So this is not enough information. Right? So let me go back and correct my my previous mistake. This is also not possible. Okay. And reflective, size, and angle. When two triangles overlap, there may be additional congruent part. Okay, so whenever you guys see two overlap triangle, I want you guys to redraw the two triangles. So then here we have this triangle on this side and this triangle on this side. So we're given that these two angles are congruent and these two angles are congruent, right? And they share the same size. Okay, so then they are congruent by angle, angle, size. And similar here to the same thing, right? So when you redraw, it doesn't have to be exact, as long as it helps you to imagine what it looked like, right? So we're given that these two angles are congruent, and we're given that these two sides are congruent, and these two angles are congruent. So we have angle, angle, size. So angle, angle, size. So these two are congruent by angle, angle, size. Okay, so whenever you see two overlapping triangle, redraw the two triangle. Okay, so then here we're saying that indicate the additional information needed to enable us to apply the specific congruent postulate. Right? So here we went through by angle, side, angle. So we have side and angle already. So we want to show that another angle. Right? So then we say that angle B must be congruent to D. So then this gives us angle side angle. So we need to label our diagram. Right, and then for the next part, I'm going to use blue. I'm going to erase this part. Okay, so we want to show that side angle side. So we have side angle, so we need a side, so then we can show that side CA is congruent to FE. So then this becomes side angle sides. Right. Right. And then for angle sides, so we have angle, so we need another angle, so then we can show that A and F are congruent, so it becomes angle sides. Right? Okay, so your assignment for tonight is on worksheet 3A. Okay, so let's review the four theorems we can use, right? So we can use side, angle, angle, or angle, side. So these are the only four that we can use. Right, so then that's the end of our notes.